Is it over? Do you still blame all your lovers? Do you suffer? Do you tell lies while you ask for more? Do you start wars? Oh, tell me, cause I got to know. Let me know. Do you still got a heart made of stone? Down below, there's a beauty that you never show. Who's gonna save you now? Who's gonna hold you down? No, let me know. Do you still got a heart made of stone? These years didn't change you for the better. No, no. Still love being bitter. Think you're clever. Yeah, yeah. Is this what you're striving for? Heartbreaker. Yeah, yeah. Don't come here for favors. See you later. Let me know. Do you still got a heart made of stone? Down below, there's a beauty that you never show. Who's gonna save you now? Who's gonna hold you down? No, let me know. Do you still got a I was so desperate for your love. I was in free fall, 'cause I was not enough. I tried to do the things you used to like. I don't know if I did it wrong, 'cause I never was enough.
Hello. Welcome to the stream today. So, yesterday, we got this physics engine optimized. We got 10,000 of these particles running at like 10 frames per second. So one of the things we figured out though is this is actually being throttled almost by the rendering, which is taking about 5 ticks per second off this. Found out if we went into the rendering right here and disabled the part where it updates the renderer or the renderer data. Oops. So now you'll see everything's bugged because it's not updating the renderer, but you'll see now the ticks will go up to like 13 at max instead of 8. Or at least it should. It seems to actually be running a bit slower this morning. I don't know if the like processor is booted up, or it should still be running in high performance mode. Yeah. So I don't know why it's that's weird. Anyways, I'm not happy with this. I think that I should be able to get like 10,000 of these. So this is 10,000 of these particles. I think I should be able to be getting 10,000 of these running at 50 ticks per second. So what I'm going to do is I'm going to figure out where exactly the slowdown is coming from. See if I can optimize that. So the first thing I'm going to do is I'm just going to disable all the collision and just make the particles move every time. So now we'll see how much of an FPS improvement we should get, or we get. So 20 ticks per second, we get about 10 ticks per second improvement. I am not happy with that. I think it should 100% be able to update 10,000 of these per second. So now we're going to try disabling updating the transformation. Oh, 50 ticks per second. Okay, so let's see what part of updating the transformation. I'll try disabling this part. Updating GUI. No, so it's not this. Oh my god, so that still gives it 30. That only takes off 10 frames per second. So there's something in this update transform function, I believe. Alright, update absolute transform. Calls the 3D transform function. The rotations, the scales. Oh, it calls S-list lock on these update calls. Because I guess this can be called from multiple threads, or at least I designed it that way. So let's try. So it has no children, so this shouldn't be the issue. I'm pretty sure it's the synchronization, because thread synchronization is really slow. So I'm going to try disabling that, which will also actually end up disabling this rendering. Yep, 50 ticks per second. Oh my god. Okay, so let's remove the synchronization now. Oh my god, 50 ticks per second. Holy shit. The effect of thread synchronization. Okay. So this is one thing I think I'm going to go through and do today. I'm going to test switching the engine over to a single update and rendering thread. Because apparently that synchronization between the update and rendering thread is like killer. That just makes me wonder though, there has to be, like, I could do actually a better way of this without synchronizing. So part of the issue I think with this S-list lock, I'm 99% sure it's just the mutex in it. It's making it so slow. So, gonna try removing the mutex parts, the synchronization, and we're gonna see if that has the same performance increases for moving. Oh my god, it does. Okay, so it's all the mutex synchronization. So basically, I can do a separate rendering and update thread. I just need to have a way to update this stuff without synchronizing. So for the render calls, there's basically no way that I can modify that list, but instead what I think I should do now is create some system where it doesn't synchronize, it just updates like a flag value, like a boolean. And then this part where it's actually slowing down in the update transform doesn't actually need the full synchronized list with multi-threading. So what I could do here is also add an option for non-locked synchronized lists. See, and then there's the other approach of just doing this all in a single thread, where it doesn't need to do any synchronization. Yeah, so this actually makes me think there's a way better way that I can do a lot of this. But that's my issue, is it would require looping through all of these. So let me think about what's happening. It's calling a transform update call. Yeah, so it's literally just the mutex slowing this down so much. That makes me not want to use these mutexes anywhere. So what I'm thinking that I could do is I could add up the render calls across the update thread without a mutex, and then right at the end of the render call I can call the mutex once. So I'd have to change how... That wouldn't be that hard, but I would have to change how it adds render calls. And then this doesn't need a mutex. The whole thing is, though, it needs this slist lock and unlock, because if this transform update function ends up calling a function that removes the transform update call, something from this list, it wouldn't be synchronized because it's iterating through it. So that's part of what this slist does. So yeah, I can optimize the shit out of this, I think. Alright, I can keep this format and optimize it. So I'm just going to keep all of this. Wait, so let me see how fast this is without updating the transform and with collisions. Actually, you know what? I'll optimize it first. Okay, so first I'm going to add an option here for being multi-threaded. Alright, there we go. So now I'm going to need to set each of these as threaded. When I initialize each of these. What thread are the synced calls called on? I think it's the update thread only. Yeah. Oh wait, what the shit? It's calling it on the render thread? Aren't these just used for deleting? Yeah, these are just used for deleting. Okay. Let's switch these around. Alright. Ooh, event calls does need to be synchronized. Ooh, okay, apparently there's a bunch of places I've used slists, so I'm gonna need to So I actually don't think this needs an S list. I think this is just a list. Like, I actually think I can delete this. And it's not used for anything, and I could do the exact same thing by just adding another render call, because I already have a render call list. Oh man, I forgot about this duplicate function. I need to implement that in a few other components. Okay, so I think this GUI text here, I can just replace the render call. Where is it? Oh yeah, so this is for blinking the cursor. Pretty sure I can just add this to the normal render calls instead, so just do render calls like this, and all the blink cursor function does is update the uniform data. So what I'm doing right now is I found out that each of these, this S list is a synchronized list. It lets you, it does multi-threaded list operations, but it also, the key thing actually that I use in my engine is it lets you add and remove objects while you're iterating through the list, and it adds it to a secondary buffer and then adds it all when you stop iterating. But the issue I found, I use it basically everywhere. And I was starting to do this physics and testing out doing 10,000 particles, which I thought should be pretty easy. I thought 10,000 wasn't a lot, and I was only getting 10 FPS, and I tested and like it wasn't the physics. And then I thought it was the rendering, and I found out it was part of the rendering, but it wasn't the actual rendering code itself. It was each time it was updating the transform after updating the rigid body here, it goes and synchronizes, it uses a mutex to synchronize with the rendering thread to update the data, the uniform data in the rendering thread. That mutex synchronization absolutely kills the performance. And then I found out that I'm using that basically everywhere, and even when it's not locking the mutex, like even when there aren't separate threads running, even if it's the same thread. So now I've added a feature to this synchronized list object that lets you toggle whether or not it's threaded. So all of these synchronized list calls that aren't threaded or don't need to be threaded now actually aren't, and I should get a huge performance boost. So now I'm just going through and changing all the code to suit that. So let's see how this works now. 50 ticks per second, absolutely amazing. Oh my god, that's awesome. Okay, so I still want to get a benchmark now. I want to get a reference for how fast this is, because I still have an optimization to make. The one thread that I do need to synchronize is one list that does need to actually have a mutex on it is the render calls, because it gets added and removed from the update thread as well. But I found an optimization I can do of adding all of the calls on the update thread. If I'm calling it on the update thread, I can add it to a secondary list on that doesn't have a mutex, and then at the end of the update call, I use the mutex and add all of the entries at once to the synchronized list, so it only has to synchronize once. Okay, so basically what I'm going to do here is I'm going to turn this up to like 50,000, or until it doesn't give me 50 ticks per second, so I can get a reference of how fast it's running. Yeah, that's a good reference right there. So I'm going to see maybe 20,000. And then I'll see how much removing the updating speeds it up. So yeah, that hovers around 30. Okay. So now let's see what happens when we remove, where is it? Here we go. So this single render call is where it synchronizes with the render thread with the mutex that slows it down. So let's see how much of an improvement we get from removing this. 50 ticks per second, yeah. So that's definitely what's slowing it down. Now let's see if it can do 50,000. So you gotta realize all it's doing here in the updating is it isn't doing any actual physics collision calculations. All it's doing is adding the gravity to the velocity, adding the velocity to the position. Insanely simple movements, but then it's also updating the transform, and then it has to send that transform data to the GPU over the uniform data. Oh my god, okay, so still 50,000 without rendering. Let's see if we can do 100,000 without rendering. See, this was what I thought was messed up yesterday, is I had no idea it was the updating transform. Oh my god, so it can do 100,000 particle updates. Starts, oh my god, goes between like 35 and 45 frames per second. That's actually really good, I think. 100,000, even though there's no collisions. Before, when I was doing the calculations, the collisions don't actually add that much when it's optimized in the grid structure that I made. Okay, so let's figure out how to optimize this now. So one of the key things I have to look at is if this single render call is called from the rendering thread, then it won't work. The only way this optimization will work is if all of these single render calls are from So this single render call is the main culprit, because that's what's used for all of the updates, for sending the signal that all the things are update. Or it's basically what oh man, it's so complicated. There's so many things to this engine, but optimization is a very tricky thing. The key thing here is to actually test it, though. It would be ridiculous. Like, I actually think it's crazy. There's so many pieces of software now that people just don't test. Like, even this isn't a good enough test. I should be going and checking this on other hardware. That's so funny. It was running at 35 FPS before, now it's running at 45. Windows threading is a hell of a thing, too. Okay, so let's look everywhere that we do this single render call. Yeah, so as far as I'm aware, it's only called yeah, hell yeah, okay. So what I'm going to do is I'm going to create another list. this list is gonna be render call buffer. I can actually construct the list right here. And then I also need to delete the list to free the memory. Ooh, that's a good thing to comment. I forgot I added this. So if there's no window, it adds all of the input, the global input variables, so that everything will still compile properly, even if there actually is no input. Okay, so then what this is going to do is... to open up the editor code, because that's where we're going to edit. First, we need to go to the update thread, which is right here. Okay. So through here is where it's, in here is where it's going to call these update calls. This is where it's going to add the single render calls. Then or to the buffer, then we're going to add the single render call buffer to actual list. So I don't think I've made an add multiple function. No, okay, so I should make that. Because I don't want to synchronize it multiple times. Okay. Add multiple objects to list. Hey, Wired Life, just greetings, just a thought on threading. There exist papers on lock 3 algorithms. Yeah, so I'm doing as much of it lock free as I can. But like, there's basically no way, like for the rendering, since the list like has a specific order, I literally need to have like a mutex locking it, or it would have a race condition. So all I'm doing is reducing the number of times I need that mutex. And I believe that's all I can do. Or make it single threaded. And the only lock-free algorithm I can think of is just looping through. Basically just you have like and so that's the other thing is like this has order, so I can guarantee that when I call the update function it's actually going to go through and call it. Like, the only other way I found is having a whole bunch of flags of which things I need to update, so then I can just set a flag, and it shouldn't have, like, the only race condition will be as if it's already updating that flag. But that's the whole thing, is it still has a race condition. I'll search that up, though. Oh yeah, it's just not. It's just a non-blocking algorithm, right? I would need to have to chunk. Like, it works for certain things where I can chunk the data, but a lock-free data structure increases the amount of time. See, this is the thing, is this isn't even a data structure. This is literally, like, just sending the data across to the rendering thread. The way I would get away from using locks is making the rendering thread the same as the updating thread. And that, it's like a trade-off. Alright, I need to code this optimally. I wonder if I have an add multiple empty function. No, I don't. Okay, this is easy though, I can just call this myself. Oh my god, this code isn't optimized. It's not that bad. But I could store these pointers. At least the add multiple here will be optimized. That'll be what's really the most heavy. Alright, there we go. Let me just make sure this is the same. Yeah, okay, iFunction. Alright, so now we need to make it so that this single render call adds to the single render call's buffer. Okay. Oh, that's supposed to be buffer. Too few arguments for call. Oh, it's just what I typed. Okay, so what is compiled? What is the code like? Alright, I have everything set up. 100k particles. It broke. Okay, so something's broken about it. Because oh, I think this might be it. No. So 40k is pretty good, but the question is, why isn't it updating? I think it's something with this slist add. Oh, it's not incrementing this. The object pointer. Okay. Okay, it crashed. Alright. Progress, I guess. Maybe calling it outside of here. No. What's the memory usage like on this? 108 megabytes for 100k particles. You know what? That's actually pretty good, I think. 180 megabytes for 100k particles, and each of those particles is an object with components. That is actually amazing, I think. Each of those objects. Oh, wow. Like, I did a test in Unity and I could barely get 5,000. So, hell yes. Now I just need to make it not crash. Oh! I need to make sure that this is 0, I think. I think if this... What happens if count here is 0? It tries to expand. Does nothing. If count equals... Wait, actually... If length does not equal 0, then call it. No, so let's make sure this is what's crashing it. Yes, okay. So something I changed when it changed it to increment the pointer here. Oh my god, that's not a pointer. Holy shit. Oh my god. No asterisk beside it. That explains it. Oh my god, I should have known. Alright, that's actually phenomenal. 40 FPS with 100k particles. Holy cow. Oh man, it's using 400 megabytes now though. Whoa, that's so interesting. So the memory spiked up to 400 megabytes and then went back down to the 180. If I had to guess, that is the GPU memory. Okay. So now we're going to lower it back down to 10K. Our original issue. So yesterday I wrote this down in the comments. 0.239 ticks per second with 10K particles. So that's what I was getting yesterday with the completely unoptimized version and with none of the optimizations I changed today. So now we're going to re-enable the collisions. And the main physics code. And now that we have everything fully optimized, we're going to see how this runs. "16 ticks per second. Not bad. So, if I'm right, the main lag from this comes from the physics now. Right here. So if I disable this, just to make sure this is actually it. Yeah, okay. So without the collisions, we get 50 FPS. With collisions, so now I'm going to try updating this grid. I'm going to see if this really negatively affects it. I don't think it will. No, no change. So now we'll see if we can optimize the physics a bit more. I believe part of the issue right now as well is that these are such small particles. Oh yeah, so it's only using 35 megabytes right now. That's really nice. So I believe I should be able to optimize the collisions even further by increasing this grid size. So if the particle's radius is 0.3, the max grid gap I can have is 0.3. So we're just about there. But let's see if this gives us much more FPS. This should use more memory because it uses more grid spaces to store the objects, but then it has to search for less objects surrounding Oh man, 40 ticks per second with 10k particles. Oh my god. And so this can get even better. So I can change the precision now and the radius. Not only making this more visible, oh, it's interesting how the frame rate is dropping. Firefox is, I think it's fighting OBS and Firefox for the other threads or something. That's really weird how the frame rate's dropping. Oh, is it because I didn't have the window in focus? That's really weird that it slows down so much. I guess it also has to remove the particles from the grid positions. It is just going down though, that's not... It makes me wonder if it's using the GPU. Yeah, it's using 10% of the GPU. That's so weird how it's flickering on. The GPU usage is flickering on and off. Oh my god, what is going on? Look at it. So for all of the operations, the GPU is flipping on and off. See how every once in a while it flips to 0%? What is going on? That's, I'm pretty sure, what's killing this. Huh. I never noticed that before. I should have been paying attention to the GPU. Why is it doing that? It's not even using 100% GPU, but it's dropping. I wonder if it's using the Intel GPU. Alright, so let's try and improve this a little bit. Let's try and fit more in there. I'm also going to change how it places the particles, I think. I think it's going to I'm going to make it place them in a grid now. Alright, so now the position is going to be... Alright, so now it'll place the particles in a grid. And this should have an interesting effect. Oh yeah, so they're colliding each other, damn. Okay, I'm gonna need to fix that. Okay, another thing I'm going to go through and implement now is instead of doing this constant physics to the epsilon, I'm going to add the precision for epsilon right here. So now instead of adding the epsilon here, right there. Okay. So now I can also much easier test how changing the epsilon affects it. Alright, where else did I use that? Oh yeah, right here. Oops. So epsilon like that. Alright. Okay. Oh my god, that's crazy. Oh my god, it's actually like water! And it's running at 50 ticks per second. No way! No way! Oh my god. I am so happy right now. This is like, yes, when all your work optimized. So that's super interesting. If you look, none of the spheres are actually, it looks like none of them are moving on the X and Y. It's all Y velocity. There's no X movement. It's all Y from gravity, but there's still creating these waves.